Now let us solve the integral of e to the power of negative x squared from 0.2 to 1 using the single-segment trapezoidal rule. The exact value of this definite integral represents the area under the curve of the function between the two bounds. This area is illustrated as a blue shaded region. Geometrically, the trapezoidal rule works by approximating the area under the curve with the area of a trapezoid. This trapezoid is formed by the straight line that connects the 2 points, f of A and f of B, as shown in the animation. Now, let us substitute the given values and calculate the estimated value of the integral. A represents the lower bound of the integral. In our case, A is 0.2. B is the upper bound of the integral. In this example, B is 1. Next, we calculate the function value at A, which is f of A, and the function value at B, which is f of B. Now we apply the trapezoidal rule formula using these values. The estimated value of the integral, using the one-segment trapezoidal rule, is approximately 0.5315. In question 6 we are asked to apply four-segment trapezoidal rule. First, we divide the interval into 4 equal parts. The total width is 1 minus 0.2, which is 0.8. Divide that by 4, and we get h equals 0.2. To split the interval, we need 5 points. Let's find them. The first point, x0, is 0.2. The second, x1, is 0.2 plus 0.2. That's 0.4. Next, x2 is 0.4 plus 0.2, which gives 0.6. Then, x3 is 0.6 plus 0.2, which is 0.8. Finally, x4 is the upper limit, which is 1. Now we have our 5 points. We'll apply the trapezoidal rule to each segment. Then add them up to get the total area. We have seen how the composite trapezoidal rule works by using 4 trapezoids to approximate the area under a curve. Now, let's write the general formula for the composite trapezoidal rule and use it to solve the given problem. First, substitute the values of h and n. Here, h is 0.2 and n is 4. Next, expand the summation and plug in the function values we obtained earlier. Then, simplify the expression. The estimated value of the integral using the four-segment trapezoidal rule is 0.5517.
Next, we estimate the integral using a single application of Simpson's one-third rule. First, we calculate the step size h by subtracting the lower bound from the upper bound and dividing by 2. Here, a is 0.2 and b is 1. Now we find x sub 0, x sub 1, and x sub 2. X sub 0 is the lower bound of the integral, which is 0.2. X sub 1 is x sub 0 plus h, and x sub 2 is x sub 1 plus h. Next, we find the function values by substituting x sub 0, x sub 1, and x sub 2 into the integrand. Finally, we substitute the value of h in the function values into Simpson's one-third formula. This gives an integral estimate of 0.5493. Next, we estimate the integral using the Composite Simpson's 1/3 rule with 4 segments. First, calculate the width of each segment as b minus divided by n. Here, a is the lower limit, b is the upper limit, and n is the number of segments. Substituting the values gives h equals 0.2. Next, we compute x sub 0 through x sub 4. X sub 0 is the lower limit of the integral, and each new x is the previous x plus h. Next, we compute the function values by substituting x sub 0 to x sub 4 into the integrand. Finally, we substitute the value of h in the function values into the Composite Simpson's 1/3 formula. The n value, which is the number of segments, is 4 in our case. In this method, the first term and the last term are used as they are. Function values with odd subscripts are multiplied by 4, and function values with even subscripts are multiplied by 2. So f of x sub 1 and f of x sub 3 are multiplied by 4, and f of x sub 2 is multiplied by 2. This gives an integral estimate of 0.5494.